All right, this is the answers to question 20. So the picture is over here. The car drives straight off, means horizontally, no angle, 54 meters high, and it lands 130 meters from the base of the cliff. So the question is, how fast was the car traveling when it went over the cliff? So let's make our horizontal and vertical Sudokus. So horizontally, they don't really, I mean, this is kind of understood. This is x equals 0. X final is 130. V naught is what we're looking for, so question mark. A horizontally is 0. And T, we don't know. We don't know when it landed. So you're looking for V naught. And you might think, I'm going to use the position function. And so let's set that up and see what happens. Let's do it down here. So x equals x naught plus V naught T, right? Because you know this whole row. So that's a clue that let's use the position function, and A equals 0. So that term is going to go away. Yay. That's promising. And we know the output of the function is 130. We know the input is, or sorry, we know the initial location is 0. And then you say, oh, I don't know V naught and I don't know T. So up to now, your brain might say, oh, I don't know T. Let's use don't know, don't care about time. But I think, I'm going to go ahead and do this. And then V squared equals V naught squared plus 2A, x minus x naught. Since acceleration is 0, all you're going to get from that is V initial equals V final, which you already knew. Okay, so not helpful. Okay, so I just wanted to show you that because in the olden days, meaning 2 weeks ago, don't know time means let's try don't know, don't care. Now, if we're doing two-dimensional problems, don't know time is a clue that you're like, hey, I haven't used the vertical column yet. Time is the crossover variable. Remember, it's like the secret passageway from horizontal to vertical. So y naught is 54 meters, I believe. Y final, this is what's tricky, y final is 0, and that's not stated in the problem, but it hit the ground, so it has no more altitude. Okay, just like the baseball lab. This is also tricky. V naught in the y direction is 0, not whatever its launch speed was. It was not launched up at all, so up and down, it wasn't moving. A is negative 9.8, and T is what we're looking for because that's a secret passageway back to the horizontal. Okay, so the fact that we have these two things is a clue that we are going to use the vertical position function. We ended on the ground. We started 54 meters above the ground. Yay, that term is 0. That means V naught y. It's kind of sloppy. Not launched up and over, but it was decelerating at 9.8 or being pulled down at 9.8 over 2 t squared. You can use your quad, or you can do some good old algebra. I'm going to do the algebra because you know how to use quad. So you would get 54, bringing that over to the other side, negative 54 equals minus 4.9 t squared. T squared equals, sorry, I'm looking for the, I'm trying to pause video. Okay, sorry. 54, I'll just do it out loud, 4.9 to the square root, 3.31, yay, just checking my work. T squared was 11.02. T equals the square root of that, which is 3.32 seconds, which is what I had in the answer key, yay. That is the time in the air. Remember, that's the secret passageway back to the horizontal. And now we are all set. It gained 130 meters at a constant rate. Let's figure out what that rate is. It did that in 3.32 seconds. Dividing both sides by 3.32, the V naught was 39.2 meters per second. Check. Okay, hope that problem went well for you. All right, question 24 is about a Major League Baseball player. I don't know why they said in excess. They're just trying to impress you. Just clearly you need a number to do the problem, so 41. And how much will it drop? So they want you to find this distance here by the time it reaches the catcher, who's 17 meters away. Okay, so there's your picture. Let's take what we know from this picture and see what goes in the horizontal and what goes in the vertical. Okay, so for the horizontal, we can imagine starting the measuring tape here. So X initial is 0. The pitcher is 17 meters away horizontally, so that's X final. V naught is 41. A is 0. We're ignoring air resistance, so there's no pushes or pulls left and right. And not surprisingly, we don't know time because we're practicing doing both columns, so we're going to get the time from the vertical. Okay, the vertical's a little bit tricky because you don't know, you know that it's thrown from some height, why not, but you don't know what that is. So the easiest thing to do is to say, I'm just going to redefine that as 0, and what I'm looking for is Y final, and I'm going to end up below where I started. V naught in the Y direction is 0. It's launched horizontally, and A, because you're on planet Earth, is negative 9.8. So let's do it here. Y, you know more about the position, right? So we're going to start with the position function. We don't know what Y is. That's what we're looking for. Y naught is 0 because we didn't know it, so it made sense to call that the reference. V naught in the Y direction is 0. A is negative 9.8 over 2t squared. And then, oh, psych, Ms. Groppy did it wrong, and I've done these problems a million times. Not a problem. You have two unknowns. That means let's go look at the other column. Let's go look at our horizontal Sudoku and see if we can get it from there. So somebody asked me in class, horizontally, since you know there's never any acceleration unless I give you a challenge problem with a jetpack, you can start with this. Someone said, can I just start with the equation that's in my notes? Yes. I'm going to give you the whole position function on the formula sheet, so I'm not going to separate it for horizontal and vertical, but if you want to just start with this knowing that that's gone, that's completely fine. So horizontally, the output of the function was 17. Input, or no, sorry, I keep saying that. The original location was 0. It was going 41 meters per second, and that will tell us the time. So divide both sides by 41, and that gives you apparently a time of, under half a second. That's 0.415. It's written prettier there. Okay, awesome. Secret passageway back to the vertical. And then we can finish this. So Y equals minus 9.0 over 2 is 4.9, because we've done that a million times, times 0.415 squared, and you get negative, because it ended up below where it started, 84 centimeters. Okay, and so on the test, if you said positive or negative 84, because the question said, how much will it drop, right? So the minus sign is understood, so it's fine if you have it in there. It's fine if you just say 8.84. Okay, so again, if you like Miss Groppy did, I just was like, oh, I care about this. Let me get started on this, and you can't solve it. Go to the other column, and that's where you're going to get the information that you need. All right, question 28 is good practice. It's a little bit tedious because it's kind of the same problem twice, but do as much as you need to get practice. So it's great to have more practice. So baseball player A bunts, which means it's just launched horizontally. Initial velocity of 1.9 parallel to the ground. Upon contact with the bat, the ball is 1.2 meters above the ground. Okay, so that's all about player A. I drew the picture in a second. Player B wants to duplicate the bunt, but he is taller, or his hands are taller. So the question is, again, this is interesting because it makes the problem more interesting, that like, hey, if somebody's taller, what's their speed relative to the other person's, right? So it's a more rich question, but it is a little bit like the same question twice. Okay, so this is player A. We're going to do that one in purple. We know more information about A, right? We knew the speed. So we're going to start with player A. So let's do the physics Sudoku horizontally. The initial position is 0. We don't know the final position. That's what we want. The initial velocity is 1.9. The acceleration is 0 because it's horizontal. And we don't know the time. And let's see. I'm trying to figure out in advance. Do we know more about the horizontal or know about the vertical? I think we're going to start with the vertical. So vertically, y naught is 1.2, hitting the ground. Remember the baseball lab, hitting the ground. That's why I think we're going to start with the verticals. We know the initial and final for the vertical. V naught is 0. There was no ups or downs of speed. And A is negative 9.8. So, oops, there's a t plus at squared over 2. So we hit the ground. We started above the ground. We didn't launch it upwards or downwards, and A is negative 9.8 t squared over 2. This gives you a time using quad or algebraically solving it of 0.495 seconds. For a reference, while I am writing, the negative 9.8 over 2 is 4.9. So if you work through the math, if you plug in t equals 1 second, the position that it's fallen in 1 second is 4.9 meters. So anything less than 4.9 meters should give you a fraction of a second, an under 1 second. Okay, so now we can secret passageway back to the horizontal and figure out how far that went. And no acceleration. So x equals did not have a head start, was heading over at a constant rate of 1.9 meters per second for about a half a second. So I get 0.94 meters. So that is a bunt, like that's not quite even a meter. That's a real bunt. Okay, so that information is what we're going to carry over to the second baseball player. All right, so this is baseball player B, and they are taller. So this could be a logic question on the test where I don't give you numbers, and then what I want you to reason through, and I would ask you, do they bunt with a faster speed or a slower speed? And what I want you to think about is this person is a little bit taller than the last person, so it's going to take a little bit longer to get to the ground. So since it's going to spend more time in the air to get to the same distance, which is what we wanted, he, she, or they will not need to bunt it with as much speed. So let's see if that happens. So if you remember, baseball player A was hitting it at 1.9 meters per second. Okay, so what do we know more about? I think the vertical again, right? So y naught is now 1.5, still hits the ground, still launched flat out horizontally, still on Earth. So let's use that to find the time. Oh, oops, I'm using X instead of Y. Hits the ground, 1.5 meters, not launched up or down, minus 9.8 t squared over 2. Using quad or algebra, you get a t of 0.553 seconds. So a little bit more time than the, I think it was 0.45. I'm getting my problems confused. Anyway, that's the time in the air. I have to scroll up on my second screen. Never mind. Okay, that's how much time this baseball is in the air, a little bit longer. So x equals x naught plus v naught t, no acceleration. We want it to be the exact same bunt. We don't have a head start, and we're looking for v naught, but I have 0.553 seconds to travel. So your v naught is 1.70 meters per second, which is less than the 1.9 meters per second because it had more time in the air. Okay, so again, a little bit of this same problem twice in a row, but that's like a more rich problem because it's asking you to kind of think through, oh, if I throw the baseball from higher up, it's going to spend more time in the air, so my final speed should not have to work as hard. Or my initial speed, my horizontal speed, can be less because I have more time to gain ground. Okay, hope that stuff made sense, and I will see you in class.